Welcome back. In this episode, we're going to explore high-level significant weather charts, SIG WX. These charts are essential for pilots flying at higher altitudes, typically above 24,000 feet. They help us understand the weather patterns that affect aircraft at cruising levels and identify potential hazards like jet streams, turbulence, and thunderstorms. High-level SIG WX charts focus on large-scale weather patterns that can influence high-altitude flight operations. They provide critical information for flight planning, ensuring pilots avoid areas with severe turbulence or extreme wind shifts. Let's start with how these charts are structured. Similar to low-level SIG WX charts, the high-level SIG WX charts are color-coded to indicate the severity of various weather phenomena. For example, severe turbulence might be marked in red, while light turbulence is marked in yellow or green. High-level SIG WX charts typically show wind direction and speed, cloud cover, and turbulence. This data helps pilots determine the best cruise altitude and avoid areas of significant weather, such as wind shear or convective storms. Pilots use this information to adjust their route and ensure a smoother and safer flight. Next, let's focus on jet streams. A jet stream is a fast-moving air current found at high altitudes, typically between 30,000 and 40,000 feet. These streams can significantly affect aircraft speed and fuel consumption. The high-level SIG WX chart will show where strong jet streams are located, allowing pilots to take advantage of tailwinds or avoid headwinds to optimize flight time and fuel usage. In addition to jet streams, high-level SIG WX charts also highlight areas of convection. Convection refers to the vertical movement of air, which is associated with thunderstorms and cloud formation. Pilots need to be aware of convective activity, as it can lead to severe turbulence and lightning. If a chart shows strong convection in an area, pilots will adjust their altitude or route to avoid the storm. Let's look at an example. Flying from Los Angeles to New York, the chart shows a strong jet stream over the Midwest. By adjusting your altitude, you can take advantage of the tailwinds and reduce your flight time. However, the chart also shows convection developing along the East Coast. This would require a change in your route to avoid the thunderstorms associated with the convection. Another important factor on the high-level SIG WX chart is wind shear. Wind shear occurs when the wind direction or speed changes abruptly over a short distance. This can create turbulence and disrupt smooth flight. The high-level SIG WX chart will highlight areas of wind shear, especially near jet streams or storm systems, so pilots can adjust their flight level accordingly to avoid these turbulent areas. Let's discuss cloud cover at high altitudes. High-level SIG WX charts show the locations of cloud layers, particularly cirrostratus and cumulonimbus clouds, CBS. These clouds can create ice and turbulence, so it's important to understand their position when flying at high altitudes. If a chart shows large areas of CBS or thick cloud cover, pilots will need to make altitude adjustments or plan to avoid these areas. Next, let's look at polar routes. Pilots flying over the North Pole or South Pole rely heavily on high-level SIG WX charts to navigate through extreme weather conditions. These charts show areas of extreme cold and polar vortex activity, which can significantly affect flight operations, including fuel efficiency and engine performance. In addition to jet streams and convection, high-level SIG WX charts provide information on tropical cyclones or hurricanes. These storms are tracked at high altitudes to help pilots avoid them during long-haul flights. The charts show the location, intensity, and movement of these storms, allowing pilots to adjust their route to avoid the most dangerous parts of the system. Let's talk about the limitations of the high-level SIG WX chart. While these charts provide important information, they are not perfect. They do not account for local weather variations that might affect a specific route or airport. Pilots should always combine high-level SIG WX data with real-time METARs, TAFs, and ATC advisories to get the most accurate picture of the weather. The high-level SIG WX chart is updated regularly, usually every 6 hours. Pilots must keep checking for updates during the flight, especially when weather systems are changing rapidly. If new systems develop or old ones dissipate, pilots must adjust their route to maintain safe flight conditions. Another key consideration is thunderstorm development. The chart provides information about the intensity and location of thunderstorms that may affect flight operations. Cumulonimbus clouds, CBS, are a primary indicator of thunderstorms, and these areas are clearly marked on the high-level SIG WX chart. Pilots must avoid flying through these areas, as they can produce severe turbulence and lightning. In summary, the high-level SIG WX chart is an essential tool for pilots flying at high altitudes. It provides critical information about wind patterns, turbulence, cloud cover, and jet streams that affect flight operations. By studying this chart, pilots can avoid hazardous conditions and optimize their routes for fuel efficiency and flight time. In the next episode, we'll continue with high-level SIG WX Part 2, where we'll go deeper into real-world applications of these charts, including how they're used in long-haul flight planning, tropical storm avoidance, and weather pattern predictions. See you in Meteorology number 57, High-Level Significant Weather Charts, SIG WX, Part 2.